Alrighty, looks like we got some people here now. I'm just setting up the screen and all that. Okay, so you guys said you wanted to go over what he said would be on the test. So that is exactly what we will do. So find the derivative of a function, find the derivative as a rate of change, finding the point on the graph of a given function that results in a certain slope, equation of a tangent line at a specific point, two functions that have the same slope, so limit theory, implicit differentiation, and logarithmic differentiation. So this test sounds like it should be a pretty easy A for all of you if you've been working. I mean, I'm sure you realized after the last test that normally his tests are not unreasonably difficult by any means. So with that in mind, I think the first thing was just a derivative. So I'll give you one that's kind of a pain in the butt to solve, and I'll let you choose it because that's what they say they do. But you really get no choice on how you solve this unless you just want to spend an hour working it. Whoa, where's some good stuff? All right, well, let's start pretty simple then. So let's start with y equals 1 over x to the fourth minus 2x plus 1. So there's a few different ways you could solve this problem right here. My first bit of advice would probably be to start by moving all this to the top. And the way we do that is we can rewrite it like this. And just put it to the negative power, which is the same thing as writing the reciprocal function, right? We all know that x to the negative first is equal to 1 over x. So now if we want to differentiate this, so then dy dx is going to be equal to, so first we got to do the power rule, bring that negative 1 out front, then multiply it by the inside, x to the fourth minus 2x plus 1. Well, that's more like a parenthesis than a bit of 1. And then, so now we subtract 1, so negative 2. Now we have to do the final step of this, which is multiplying by the derivative of the inside, which should give you something like this. And then if you really want to go the extra yard, I mean, I can't stop you. So here's what I would say to write it out as. So dy dx, you could express it as the product of Something like that. Okay, that actually does look pretty visible from here, so I'm gonna keep working it. So this is actually the final answer right here. Yeah, so you can probably expect something around this level of difficulty. You might get like I don't know, for question one, I would say you'll probably get something along the lines of one of these. Question one, it just said derivative, so it could either be, it's probably gonna be product or quotient rule. And I mean, honestly, as long as you know your basic techniques of derivation well, that should, question one is probably meant to give you 3 points. So I think the next one was find the derivative using the traditional definition, which if you guys remember what the definition of a derivative is, it's just a difference quotient with a limit as h approaches infinity. So like, you may get a problem like this on the test, for example. You get something like x cubed minus 3 equals d dx. So now if you remember the difference quotient, you should take it like this. So let's see if this works. Why don't we? So f of x plus h, that's going to give us x plus h cubed minus 3 minus x cubed plus 3 all over h, which will give us x plus h cubed minus x cubed over h. Yeah, and you could simplify it further than this, but as long as you write this thing here, you'll be fine. I mean, I would advise to simplify further than this, but I don't really want to work on a summation / difference of cubes here. And for the sake of time, I'm just going to keep going. So guys, literally, like, this test shouldn't be that hard. Like, I know all of you are stressed about it because calc1 has a reputation for itself at this point, I'm sure, but this should not be too hard of a test. You guys already got the hardest stuff out of the way. What do we have here? That's kind of boring. That one looks decent. Let's see how that works. Okay, derivative at a point. So we've got f of x is equal to x squared over x squared minus 1 squared. At 2 4 over 9. Oh boy, here I go differentiating again. So let's do this, huh? No, that's not really what I want to do here. Let's do logarithmic differentiation just because I can and I want to. So ln of y equals ln of x squared over x squared minus 1 squared. So now if you remember your log properties, you should know that the numerator is positive, and we can actually take that 2 out there and make this even easier for us. And then we just got to subtract the denominator. And gosh, I keep forgetting those 2's. And now we've got a much easier problem to work with. So the next step is going to be take the derivative of the entire equation, which should give us 1 over y times dy dx, which is equal to 2 over x minus 2 times 1 over x squared minus 1 times 2x, which gives us 1 over y dy dx is equal to 2 over x minus 4x over x squared minus 1. And I know that a lot of you like to simplify these, which is a good thing actually. Don't let anyone tell you otherwise, but let's take this one more step then. And all I did was just cross multiply. I just kind of did it in my head because I figure if you're in calculus 1, you probably know how to add and subtract fractions. So let's see what this gives us. We end up getting 2x squared minus 2 minus 4x squared, which just gives us, gosh, I'm just going to write it over here. So we're going to end up getting negative 2 times 2x squared plus 1 over x times x squared minus 1. And then, of course, we have to multiply both sides by our original product of y. So we're going to multiply this by x squared over x squared minus 1 squared. And the only thing that's going to do is that's going to turn that x squared to an x, and it's going to get rid of this x on the denominator. So therefore, our final answer will look like this. We'll probably get something along the lines of this. What's up, Hayden? I don't know like any of you guys, and I would normally feel bad about this, but I've never seen a soul in this class because I don't go to this class. But yeah, what's up, student in class that I teach? I don't know. SI, normally I just like know all of your faces and names at this point, but it's like this quarantine sure does make it a weird situation. Okay, alrighty. I'm gonna take it that most of you are engineers and can probably figure out the spring problems here. I mean, it's just more of the same, guys. Like, this looks kind of cool, actually. This is a conceptual problem. Okay, so for this one, can you do the spring problem? Oh, I shouldn't have even mentioned it. Yeah, I can make a spring problem. Alrighty. So a weight hangs on a spring, making it 2 meters long. So I don't know how to draw a spring, but I'm gonna guess it's something like that. And I'm gonna draw the weight like that. If the weight is pulled down and then released, the weight oscillates up and down. The length L of the spring after t seconds is given by L of t is equal to 2 plus 2 cosine. Oh, just kidding. Plus cosine of 2 pi times t. Alrighty, so they want us to find the velocity v of the weight at time t equals 1 over 4. Oh, is that it? That's strange. Okay, so this concept right here, guys, ready? This is some physicist math right here, so you really got to pay attention because they like to do math that has weird symbols and doesn't require a lot of math. So, without further ado, I introduce you to this thing called a derivative. So, L prime of t is equal to velocity in regards to time, which is equal to 0 plus, let's see, cosine goes to negative sine. Yeah, negative sine of 2 pi times t, and then you guys should all know your chain rule at this point, times 1. So we get v of t, velocity of t, is equal to negative sine of 2 pi t. What are the odds of that? What about acceleration of t? Well, I'm going to go out on a limb here and say that it's just the second derivative. Don't worry, guys. I'm only slightly jeering at you because I also struggled with this. I'm just having fun. So then negative sine 2 pi t, that differentiates to something as well. That becomes negative sine, so sine goes to cosine, so negative sine obviously must go to negative cosine of 2 pi times t. And there you have it. You got your velocity and your acceleration. And then you just plug in t. So v of t, or what is the stupid number they gave us? They gave us a dumb number. At t of 1 over 4, so v of 1 over 4 is equal to, let's see, negative sine of, gosh, really? Pi over 2, which you guys should know that. Acceleration of t equals 1 over 4 is equal to negative cosine of pi over 2. And that's how that works. You just take two derivatives and then plug stuff in. And that's pretty much, you just took physics. I'm sorry, I like to make jokes about physics because I've literally not taken a single physics class the entire time I've been at this university, but I've taken more math than every physics major at this university. One of my good friends is a physicist, or a physics major at least. And me and him always like to just kind of jeer at each other about what all the stuff we're missing out on. Because me and him, we both were originally like, I don't even know, we both changed our majors quite a few times. Just remember, guys, if you're smart and not stubborn, you'll probably end up changing your major at least twice. And that's okay, because it doesn't matter if you change your major as long as you do good. Like, I've changed my major probably north of 4 times at this point, but I've also done research for the university and teach calculus for the university. So it's all in what you do. It's in the way that you do it, as Eric Clapton would say. Ooh, boy, implicit differentiation. Too easy. Let's find something a little bit trickier. Where are the challenging questions? No, I don't want to do that one quite yet. Yeah, you guys, like, by the way, there's this thing called a textbook. And if you really, really feel the need to study for these tests, this thing is a great resource. I'm not saying you should use the textbook, but if you happen to come to that conclusion on your own, I would be impressed. I mean, I think it'd be cool. Remember, guys, math is cool, but so is reverse psychology. Should I make you guys graph a circle? Is that something reasonable? No, it's probably not reasonable. Gosh, I just need a problem that I haven't already solved in this book. Here, this one will work. So I'm going to do an even number for my book. So I was about to say that means I'm not going to know if it's right or wrong, but I absolutely will because I don't plan on making any mistakes. So there, that right there. I said I don't plan on making mistakes, and now if I make a mistake, I have 6 people that will eagerly call it out. Oh, ha, you guys are all going to be doctors. That's funny. I went through my doctor phase too, guys. Okay. So this next thing, we're going to take the derivative, d dx, and so did Sammy. He's the physics major now, by the way. So let's think about this. We got 4 times x dy dx plus, oh, just x probably. No, just 1. No, I screwed up. What did I do wrong? No, so just plus y. Okay, there we go. Duh. Over 2x plus 2y dy dx. And I just took the derivative of the whole thing there, so like you should be able to do it at about that pace if you're really good at this. But don't worry if you can't quite yet, because we still got a good bit of the semester left. Math doesn't really start getting easier until you decide that you enjoy it. And that was something in high school I struggled with for quite a long time, actually. Because when I was a kid, if I used to miss a problem, my dad would tear my homework to shreds. But you know what? I held no anger towards that or anything because here I am teaching you all math, so I'd say it worked out pretty well. Oh, that's kind of trippy. Look at that. That's kind of cool. Neat. Oh, wow. I bet this can even be simplified a step further, can't it? It can. It can. Okay. So So that's implicit differentiation. We've done a logarithmic derivative. So here is what I am going to say. I don't know. I say we do 2 more problems, and give me a second here because I really want to find some good ones. But I'm just going to do probably 1 to 2 more problems. Then we'll call it a day because I didn't really want to do a long session. I just wanted to get some stuff in before your test. And honestly, everything I'm going over in this session, we've already gone over 10 times in the other sessions. So this should all be very, very trivial for you at this point, if you've been doing the right practice. All right, where are the challenging logarithmic differentiation problems? Like, why did they just stop making these fun after a certain point in this book? Oh, that's a good thing. That's something I should say to you guys. Yeah, you didn't ask for my advice, but you're watching my video, so you get my advice. So you can't say something is easy and say it's, well, hold on, let me rephrase. You can't say something is boring if it's difficult for you. Meaning, if someone who has an F in Calc 1 says, gosh, calculus is so boring, I would say, how do you know calculus is boring? Because you're failing it. I mean, you're not even doing well in it. Like, the most exciting part is learning new stuff, and you're choosing not to do that, and then blaming the fact that the stuff you haven't even tried to learn is boring. Like, I don't know, guys. I don't mess around. Like, I think excuses are stupid. I honestly think every single one of you is smart enough to get an A in this class. Don't let the East Cobb High School mentality that for some reason leaks into Kennesaw's area, don't let that win. Because school is not just about getting a piece of paper. If anything, what you are learning right now is probably one of the most important skills you will learn for the next year. Because this is not learning how to do math. This is learning how to solve problems. And you know what? There is one thing that people across the world like. It is a problem solver who can solve his problems in an eloquent manner. The architect of his own mind. Speaking of that, let's do some logarithmic differentiation. You know, they always say that the 10,000 hour rule is the only way to truly master a skill. I don't think that's entirely right, though. I think you probably do need 10,000 hours, but I think it's more than just time. I would imagine you probably need 10,000 hours and a stupid amount of discipline to even come close to mastery of something like math. Oh wow, look at that, 24x squared. That is a nice number. What's better than 24? 25. Okay, so, do I actually want to simplify this all the way? Probably not. So we're just gonna leave it, and I'll just plug in y. I can just combine the fractions if you guys really want me to, but I really don't want to. So until someone asks me specifically to do that, I'm not going to. Because it's the same answer. Oh snap, is that someone telling me to simplify the fraction? Nope. Okay, so this is actually the answer right here. I finished this already. See, I think the trouble this class is having is overthinking, because there's really just 5 different ways to take a derivative. You have the power rule, the product rule, the quotient rule, implicit differentiation, and logarithmic differentiation. If you know those 5 things, and you know them quite well, then you should be able to get an A on this test fairly easily. What I would recommend doing, in all honesty, is just for tonight, if you want to feel prepared for this test, I would highly, highly recommend spending a couple of hours clearing off your desk or whatever you work at, and just sit down, open up that calculus textbook you guys have, take out a notebook or a tablet or something, and just start working problems and writing notes on when you're working the problems. Because I mean, really, that's all I do, guys. Like, I mean, I didn't even really go to class last semester, and I finished with a 4.0, and like, I made an A in differential equations and didn't go. Like, if you read the textbook, and I'm not encouraging you to not go to class. If anything, I'm encouraging the opposite. I don't do well if I'm not an auditory learner. I'm a very reading learner, very much a reading learner, but I'm telling you guys, if you put in the work and you have actual discipline that you are able to control and use with your own willpower, then an A is more than within reach in this class. So that's all I got for today. If you know, a couple last notes. Derivative of distance becomes velocity. Derivative of velocity, acceleration. Logarithmic differentiation, take the natural log of everything, use log properties to move the powers of the expressions and change multiplying / dividing into adding / subtracting. Then take the derivative of the whole expression and move together the terms that have dy dx. And implicit differentiation is the same thing as logarithmic differentiation, but there's no logs. Well, there can be. I mean, logarithmic is a form of implicit. But yeah, that's all I got for today. So I hope this was helpful. I hope it's reassuring, because you really shouldn't be worried about this test too much. I would put in probably 2 hours tonight, and if you've been doing your homework and coming to all the other sessions, you should very easily be able to get an A. So I'm going to leave it there, because I think you guys are going to be fine on this test. I genuinely do. If anyone's worried, message me through the group chat, and I will gladly respond with whatever help you need. But that's all I got for today, so I'll see you all next time.